Hey guys, how's everybody doing? I'm gonna do some notes on how to solve a linear systems of linear equations by the addition method. This is also called the elimination method. This is my preferred method to solve systems of equations. Remember, we learned how to do it graphically, which is great, and then we learned how to do it using the substitution method, which is good. But again, I'm a big fan of the elimination method. It's the easiest, in my opinion, to do. A couple of comments when you're going to use the addition method or the elimination method. First of all, your equations have to be set up the same. So preferably you want to have x and y on the same side of the equal sign. And then your next equation, so if this is equation number 1, your next equation you also want to have x and y. Now I'm going to call them different x's and different y's. Right, you want to make sure that you have x's and y's on the same side of the equal sign. The next thing you want to make sure is that they line up. So you would like to have x's over x's, y's over y's, and the constant over the constant. So these are your first two steps to try to solve using the addition method. You want to make sure things line up, and you want to make sure that the x's are over the x's and the y's are over the y's. Now from there, it gets a little bit tricky, so we're going to do an example all the way out. Again, I'm not going to follow their necessarily method of doing it, but I am going to do this equation. So we're going to have the first equation and the second equation. All right, so there's equation 1 and there's equation 2. Notice they already line up, right? X's are over x's, y's are over y's. They're both on the same side of the equal sign. The next thing you have to do is you have to pick one of the two variables to try to cancel out. And you're going to cancel it out by having opposite coefficients. So I want to pick one of the two variables. It's up to you to pick. Pick one, try to pick the easiest one. Usually one will be easier than the other. Like when I look at this, I want these to either be the same value or these to be the same value. Not really the same value, opposite value. So if one is 10, I want the other one negative 10. If one is 6, I want the other one negative 6, and so on. So I think it's really, really obvious that I should take this top equation and multiply by 2. I'm going to take the top equation and multiply by 2, right? So this is going to become, so now I'm going to write a new equation. This is going to become 6x plus 2y equals 16. Notice you got to multiply everything by 2. And this other equation I'm going to bring, sorry, that should be 4y. This other equation I'm going to bring straight over. This becomes 5x minus 4y equals 1. So I multiply that by 2, that by 2, and that by 2. Now the whole point of this method, the elimination method, is that when you add these two equations straight down, those two variables are eliminated, right? So you get 11x equals 17. And you can solve for x, 17 over 11. So it's another way to eliminate, right? It's another way to eliminate. It's another way to get rid of one of the two variables. Now what would we do here? We would take this and plug it in and then solve for y, just like we did on the substitution method. Once you find one variable, you plug it in. Now I'm not going to plug this one in because this one will become really ugly and it'll be not much fun. Let's do a whole nother one all the way out. So again, the key step is you have to think about which one to eliminate and why. So let's see, let's pick another one. I'm going to look at this one down here, number 5, because this one's a little tricky. So when I look at problem 5, none of these are going to be able to be changed very quickly, right? None of these are going to be able to be changed, so I'm going to have to do something else, as opposed to this one. Up here, I would just take this top equation and multiply it by negative 1, because it would become negative 4x plus 3y equals 16, and now you see that these two y's eliminate. Now be careful, you don't always have to eliminate the y's, you could also eliminate the x's. But sometimes it's a little trickier, like if we look at problem 5, nothing is going to eliminate very quickly. So on this problem, we're going to have to do two things to eliminate it. So on this problem, I'm going to take the top equation and multiply by 3, and I'm going to take the bottom equation and multiply by 2. So the top equation is going to become negative 6x plus 9y equals negative 18, right? 3, 3, 3. And the bottom equation is going to become positive 6x plus 10y. Negative 29 times 2 is negative 58. So I did both my equations. I had to multiply both of them by something so that they'll eliminate. All right, so from here I should add straight down. Right, so I'm going to add these two down. Notice the 6x and the negative 6x cancels out. So I get 19y, let's see, 58 and 18. Well, 58 and 10 is 68, and another 8, is that negative 78? No, negative 76, third. And hopefully that divides nicely. Let's see. 76 divided by 19. It is. It's a very nice -4. So I eliminated my x and I solved for y. It turns out my y value is -4. Now it's the same as previous methods. I'm going to substitute it in. By the way, it doesn't matter where you substitute it. I'm just going to pick this top equation. So I'm going to take that y and plug it in right there. So this becomes -2x plus 3 times -4 equals -6. -2x minus 12 equals -6. Add 12 to both sides. -2x equals 6, or x equals -3. So again, my answer, my solution is -3 comma -4. -3 comma -4. So again, the goal here is make sure things line up, decide what to multiply by, multiply, and then solve the equation just like we learned in the substitution method. So I've already given you a clue on problem 3. I did the first step for you. Why don't you pause the video, try to solve problem 3. I'll be solving it if you don't pause the video, and we'll see if we get the same answer. So pause now if you want to try it on your own. Okay, let's see how you did. So remember, we had this equation. Remember, we multiplied this one by -1 to get this equation. And now we're going to add straight down. These two cancel. 5 minus 4 is 1x equals -1, right? -17 plus 16 is -1. So we get our answer. X equals -1. And again, I'm going to plug this into either equation. This time I'm going to pick the top equation. So this becomes 4 times -1 minus 3y equals -16. -4 minus 3y equals -16. Add 4 to both sides. -3y equals -12. Y equals 4. So my solution, my point, my answer is -1 comma 4. So again, as you work these problems, step 1, decide what to multiply by. Step 2, multiply by that thing and then cancel. Of course, you're already assuming that you've already done the first steps. So why don't we have you try one all on your own? Why don't you try problem number 4? Again, stop the video, try it. When you start the video, I'll be working the problem for you. Okay, I think the obvious solution here is to multiply the bottom one by 2. So this becomes 14a minus 6b equals 46. I'm going to bring the top equation down. I'm going to add these. These eliminate. 19a equals, let's see, what does that become? 38. Divide by 19. I get my value of a equals 2. You're going to plug this in up here. All right, so that becomes 10 plus 6b equals -8. 6b equals -18. b equals -3. So a is 2, b is -3, or 2 -3 if you want to write it as a point. So again, this is my preferred method. This is called the elimination method. I think it is the quickest. You can also use the substitution method if you like. And in just a few minutes, we'll be doing some word problems and some more complicated ones just to make sure you can do them. Okay guys, we're going to do a couple more problems on the elimination method. Again, so there's 3 methods to solve these systems. You can use the graphing, even though you should never graph because you're probably not going to get the right answer because it's going to be ugly. You can use the substitution method, that works fine, or you can use the elimination method. Remember, when we solve these, sometimes we get one answer, sometimes we get an infinite number of answers, or sometimes we get no solution, right? If they're parallel lines, we're going to get no solution. So I thought we'd do a couple more tricky examples just to make sure you got it. So let's try number 9. So notice number 9 is already lined up, x's, y's, numbers. So obviously I think we should take the top and multiply it by 2. So this becomes 4x plus 2y equals 8. Sorry, -8. Let's add these straight down. Those cancel, those cancel, those cancel. You get 0 equals 0. We talked about this in class. Anytime you get a number equals a number, it means that there are an infinite number of solutions. All right. And that's actually called a dependent system. So that's called a dependent system. Sometimes you get one solution, right? That is called an independent system. And if you get no solution, that's called inconsistent, right? So dependent system, the two values are dependent upon each other. They're the same, right? All right, the next one down. Why don't you take a minute? Try number 11. Again, stop the problem. Try number 11. Stop the video, and you try it. And when you turn it back on, I'll be working the problem. Okay, so when I look at this, I'm thinking I'm going to multiply the top one by -2. Negative 14y equals negative 4x plus 0. I mean, there's a 0 over there. You might not see it, but it is there. These cancel. 0 equals negative 19. This is never true, so there is no solution. This is called an inconsistent system. So sometimes when you solve these, you get other types of systems, independent, dependent, inconsistent system. All right. So again, you can use different methods when solving: the substitution method, the addition method. Either way, remember when you're using the substitution, you want to make sure one of the two variables you can get by itself nicely. Again, I'm a fan of the elimination method, or again, the addition method. And you can still do it with variables and fractions and decimals. It still works the same. It's no problem at all. All right, let's try a word problem. This is a typical word problem in this section. You're going to have a scenario, usually involving numbers, and they're going to ask you to do things and then solve the system. All right. So let's see. Set up a system of linear equations and solve for the indicated quantities. 6 times the smaller of two numbers minus the larger number is -15. Okay. 13 more than twice the smaller number is 3 times the larger number. Okay, so we need to make up some variables. So I'm going to let x be my small number, and I'm going to let y be my large number. All right, so let's see. Let's write an equation. 6 times the smaller number plus the larger number is -15. 13 more than twice the smaller number. So twice the smaller number, 13 more, is 3 times the larger number. Let's check that. 6 times the smaller number, I wrote plus, minus the larger number is -15. 13 more than twice the smaller number. So 13 more than twice the smaller number is 3 times the larger number. So I made a mistake there. That had to be minus, right? I didn't read that. I thought it said plus. All right, so we can solve this pretty much any way we want to. We could use the elimination method or the substitution method. Again, I'm a fan of the elimination, so I'm going to rewrite this bottom problem. The top problem I'm going to leave the same. All right, that stayed the same. I'm going to move the y over and the 13 over. So this becomes 2x minus 3y equals -13. I need to eliminate one of the two. Doesn't really matter which one. Let's see. I probably would take this top one and multiply by -3. -18x. A negative and negative becomes plus 3y. A negative and negative becomes 45. These cancel. -16x equals 45. Take away 13. Let's see. 45 take away 10 is 35, take away 3 more is 32, and divide by -16. So it looks like I get x equals -2. Of course, don't forget, once you find x, you got to plug it back in and find y. So the smaller number is -2. Let's see, larger number, 2 times -2 plus 13 is 3y. -4 plus 13 is 3y. 9 equals 3y, y equals 3. All right, so the smaller number is -2 and the larger number is 3. So there's a word problem on solving systems. It's very similar. You write the equations and you solve them using whatever method you want. Okay, I'm going to stop this video and then I'll have another video on the next section and we'll go from there.